Hi guys, our video today is going to be about reading graphs critically, and so I'm just going to talk about a couple things. I'm going to talk about ways that graphs can be a little bit misleading if you don't look at them carefully. We're going to talk about what a break mark looks like and in a scale on a graph, and just the features that you want to look at when you're studying a graph to try and understand it. The answer to the free response question for today is puppy chow. So we're going to create two graphs for the information from the table on the left. And this is projected U.S. college enrollment for people at an undergrad level. So this is like when you first graduate high school. And you can see that for 2013, the projected level was 18.4 million students at the undergrad level. And the reason that's still projected is because that was just last year. It hasn't been long enough for them to gather all the data and know for sure how many people actually attended college. So even though it's passed, it's still a projected value. And then you can see that the values go up from there. You can see that we're counting in millions. So I'm going to want to count in millions on my vertical scale on my graph as well. And so on my horizontal scale, I would want to put the years because that's the independent variable. So we always want to put the independent variable on the horizontal scale, and then the vertical scale is the dependent variable, which is the number of students. So for my horizontal scale, I'm just going to write those different years. And obviously, I'm only graphing the amount of the information that's there in the table. So I'm not going to start with the year 0 or anything. That doesn't really make sense. And it's not in any way dishonest or anything to just label my graph starting with the year 2013 because that's the information that I have there. So I've labeled my years on there, counting by 1 because I have information for each year. Now I need to figure out how I want to label my vertical scale. And you can see that I'm counting by millions here. So I could count by start at 0 and maybe count, let's see, I need to get up to 20 because 19.5 is pretty close to 20, so I could count by 2. That would get me up to 20 right at the top. And I would need to make sure to label that so that people knew what I was counting. So this is students and it's in millions. And down here it's pretty obviously the year, but I could write year. Okay, so now I'm going to go ahead and put my points in. So for 2013, I have 18.4 million. So I have to remember that I'm counting by 2 here. So the halfway mark between the 18 and the next mark would be 19. So 18.4 is about a fourth of the way up my scale there, if I can get it to right. 18.6, just a little bit higher than that. 18.8 is almost to the halfway. 19.0 would be exactly halfway. 19.2 is a tiny bit above that. And then 19.5 is a little bit above that. And so if I'm looking at this graph, it's kind of emphasizing, you can see that the pattern is going up, but it's really hard to see the details of what the numbers are. There's no way I could look at this graph if I didn't have the table and know exactly what amount I was talking about. And, you know, it looks like a small increase because our scale is in millions. So even though I'm going up 0.2 million from 2013 to 2014, which is 200,000 people, it doesn't look like a very large increase on this scale. But you can see how the numbers relate to each other, that these are small increases, that we're not like doubling in size or anything like that. So this graph shows the numbers and their relationship to each other accurately, but it's hard to see the details of what the individual numbers are. So if I wanted to actually be able to look at the graph and see the actual projected value, I would probably want to have these points spaced out a little bit more and have more detail on my scale. And the way that I could do that is I could count, instead of counting by 2 million, I could look at these values and say, well, they really only go from 18.4 to 19.5. So if I had my values start closer to 18.4 and end right around 20 million again, then I'd be able to see the detail better. I could put a 0 on my scale again, and then I could skip some numbers. I could skip up to 18, so I could count by 0.2 million. And the way that I show that I'm going to skip some numbers is by putting in a break mark, which kind of just looks like that. And then my next number would be 18.0. Okay, so now that I have my scale spread out a little bit more and have that break mark to show that I've skipped some numbers, I could put these points on the graph again, and we'd be able to see a lot of the difference in the values. A couple things that can be misleading about a graph that looks like that where you've skipped values or used a break mark. So sometimes on a graph scale, instead of starting with 0 and putting a break mark, I could have just started counting by 18.0 at the bottom of the scale, by 18 million. In this case, I put a break mark so you could see what that looks like. We will be using those. What can be misleading about that is it looks like that the 2018 value of students is about twice as much as the 2013 value of students. Now we know from our original graph that that's not the case at all, that those are just small little changes incrementally about the same. But when you shorten up your scale and you don't show all the values, you lose the relationship between the numbers. The relationship between the numbers and the way they look on the graph will not be true. So that can be considered misleading information. If the person creating the graph is trying to be dishonest or trying to use the graph to be persuasive, they can make changes to the scale that, if you're not looking carefully, would lead you to believe things that aren't true. So for example, if I'm trying to prove that attendance in college is going up dramatically, I would definitely want to use the second graph rather than the first graph, because if you look back at the first graph, you can see that doesn't look like a dramatic rise. It shows the relationship between the numbers more accurately, but it doesn't show this large rise. So if I was trying to prove that to people, I'd be more likely to use this second graph. And so that might be a little bit misleading. So here are your free response and multiple choice questions. You can go ahead and pause the video now and answer those too. And have a great day when you're done.